Welcome to True Projects. In this video, we are going to explain about a project titled Integrating Machine Learning Algorithms with Quantum Annealing Solvers for Online Fraud Detection. Addressing the complexity of countering the fraudulent activity in the online e-commerce transaction, we underscore the three key hurdles. The surge in online transactions propelled by mobile technology advancements, the imperative for swift real-time or the near real-time fraud identification, and the intrinsic class imbalance within the dataset. With the legitimate transaction per outnumbering the rare fraudulent one, to surmount these challenges, we propose an innovative strategy involving the fusion of quantum annealing solvers and the machine learning algorithms, enabling the robust and prompt fraud detection. Emphasizing the significance of temporal dynamics, we delve into differentiation between stationary and the non-stationary time series data, advocating for the integration of the temporal variable within the analytic model. Our objective extends to tackling the real-time detection demand and the dataset imbalance by delving into the real-time of quantum machine learning, evaluating its efficacy against the conventional machine learning methods in the context of fraud detection. And introducing this innovative project for the online fraud detection, we present a robust detection framework that harnesses the power of machine learning. Particularly leveraging the quantum machine learning, our approach involves enhancing the SVM with the quantum annealing solver, propelling the real-time fraud detection capability. Our study encompassed a comprehensive comparison pitting the performance of the QML enriched system against the 12 conventional machine learning algorithms. The evaluation is conducted across the two distinct datasets, the Israel credit card transaction dataset, which is of non-time series data, and of the bank loan dataset, which is of the time series data. This investigation aimed to showcase the prowess of QML in addressing the intricate time series data marked by high class imbalance alongside underscoring the efficacy of traditional machine learning methodology for the non-time series scenario. By offering these insights, we empower the decision maker to strategically select the optimal approaches, navigating the delicate balance of speed, accuracy, and the resource consideration in the fraud detection project. Then these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. Here we need to import the essential libraries and packages for the subsequent data analysis and the model development. And the second one is exploring the dataset. And this exploration of the dataset is conducted to gain a comprehensive understanding of its attributes, characteristics, and the potential challenges. And the third one is data processing. Raw data undergoes the meticulous processing, including handling the missing value, scaling, and transforming the categorical features, ensuring the data quality and the compatibility with the machine learning algorithm. And the next one is visualization using the Seaborn and Matplotlib. It's employed to generate the insightful graph and charts, facilitating the data interpretation and pattern recognition. And the next step is label processing. Categorical labels are encoded into the numerical format, enabling the seamless integration into the machine learning models. And the next step is feature selection algorithm. A robust feature selection algorithm is employed to identify the most influential features, contributing to the model efficiency and the interpretability. And the next one is splitting the training and the testing data. The dataset is partitioned into the training and the testing subset, enabling the model training on the one segment and evaluation on the another to assess the predictive performance. And the next step is building the model. Here various machine learning algorithms are built. The first one is SVM quantum mechanics. SPM is enhanced with the quantum annealing solver, leveraging the principle of the quantum mechanics. This approach aims to harness the quantum computing capability to optimize the SPM performance, potentially leading to the improved fraud detection accuracy. And the next one is bagging classifier. It constructs an ensemble of multiple base classifiers where each trained on the different subset of the dataset. The aggregation of the prediction from these diverse classifiers enhance the overall predictive power and robustness of the fraud detection mode. And the next one is LDA. Linear discriminant analysis is employed to model the differences between the classes as a fraudulent or not by projecting the data into a lower dimensional space. LDA aims to maximize the separation between the classes, facilitating the effective classification. And the next one is ELA. Logistic regression is a binary classification algorithm that estimates the probability of the transaction being fraudulent by fitting a logistic function to the data. It quantifies the relationship between the features and the likelihood of the fraud occurrence. And the next one is MLP. It stands for multi-layer perceptron, a neural network comprising of the multiple layers of the interconnected nodes. This deep learning model captures the intricate pattern and the relationship within the data, enabling it to detect the complex fraud pattern. And the next one is RF. Random forest forms an ensemble of the decision trees, collectively making the prediction. It takes the tackle overfitting and enhancing the predictive accuracy by aggregating the results from the individual trees each trained on a subset of the data. And the next one is OT classifier. It combines the prediction from both the random forest and the logistic regression model, and the ensemble strategy leverages the strength of these distinct algorithms, yielding a more robust and accurate fraud detection outcome. And the next one is KNN. It classifies the instance based on the class label of the K nearest neighbor in the feature space. It is particularly effective when the local pattern or indicative of the fraud presence, contributing to the accurate prediction. And the next one is RBM. Stands for Restricted Boltzmann Mission, is a generative neural network that learns a probability distribution over its set of input. It be employed for the feature learning, capturing the underlying data pattern that aid in distinguishing the fraudulent transaction. And the next one is decision tree. The partitions data based on the hierarchical decision leading to the classification outcome. It provides the transparency in decision making and serve as a building block for ensemble methods like of random forest. And the next one is stacking classifier. It combines the prediction from the multiple base classifier, enhancing the predictive performance. It introduced a meta model that leverages the output of these base models, providing a comprehensive approach to the fraud detection. And the next step is user gives the input. Here, a Flask interface enables the user interaction, allowing the input of data for the fraud detection. And the next step is the given input is pre-processed for prediction. User-provided input undergoes the pre-processing, ensuring the compatibility with the model input requirements. And the next step is trained model is used for the prediction. The trained machine learning model analyzes the pre-processed input data to predict the potential instance of the online fraud. And the next one is the final outcome is displayed. The model outcome, including the fraud detection result, are presented through the Flask interface, empowering the user to make the informed decision and to take the proactive measures against the fraudulent activities. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, and the static folder containing of the folders like assets, CSS, fonts and JavaScript files within it, and the template folder containing of the HTML documents. It typically include of home, index, results, sign in and sign up pages within it, and the APIs and py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operations, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model SAV files contain the information of the algorithm, and it loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the signup.db is a file appear to be the database file that is used to store the user information. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this, it will change the current directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it will redirect it to this page containing of information and the title of the project. Then click on the sign up button. Here it will redirect it to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here we need to enter those details of username and password, and then click on the register button. Here it will redirect it to this page containing of the input details that are need to be filled to detect the fraud. And I am entering those details as of time is 4:06 and the V1 is minus 2.3122 and the V2 is 1.951 and the V3 is minus 1.609 and the V4 is 3.997 and the V5 is minus 0.522 and the V6 is minus 1.426 and the V7 is minus 2.537 and the V9 is minus 2.770 and the V10 is minus 2.772 and the V11 is 3.202 and the V12 is minus 2.899 and the V13 is minus 0.5952 and the V28 is minus 0.143 and the amount is of 0. And then click on the predict button. Here it predicted as of the based on the input the PCA feature values of the transaction is fraudulent. In this way we can analyze the detection of the fraud by using this input details by using various machine learning algorithms with of quantum annealing. And here by clicking on the home button we can re-enter the other details of 2 and I'm entering those details 12093 for the time and the V1 is of minus 4.696 and the V2 of 3.044 and the V3 of minus 5.598 and the V4 of 5.928 and the V5 of minus 2.190 and the V6 of minus 1.529 and the V7 of minus 4.487, and the V9 of minus 1.307, and the V10 of minus 4.1388, and the V11 of 5.149, and the V12 of minus 11.12, and V13 of minus 11.3496, and the V28 of 0.3745, and the amount is of 9.99, and then click on the predict button. Here it predicted as of non-fraudulent. In this way, we can detect whether the transaction is fraudulent or not by using the various machine learning algorithms with quantum annealing. And in conclusion, the potential of quantum machine learning in processing the data set characterized with the time series high dimensional and the highly imbalanced data, which are challenging for the traditional machine learning algorithms. It cautions that practitioners need to take into the consideration the trade-off accuracy, speed, and the cost of computing, as well as the kind of the data the system works with to provide the most optimum business solution. We also emphasize the importance of traditional machine learning approaches in non-time series data, and the system and the study delivers the near real-time result, which is a significant step towards the direction of real-time fraud detection.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.